ঠিকই আছে। Dear students, welcome. This is our 8th class on dynamics. Today, we shall solve these two problems. Before going to solve these two problems, I must tell you that when a particle moves under the action of the earth, then if the particle moves outside the surface of the earth, then the acceleration varies inversely as the square of the distance of the particle from the center of the earth. Number 2, if the particle moves inside the earth's surface, then the acceleration varies directly as the distance of the particle from the center of the earth. Number 3, at the earth's surface, the value of the acceleration is equal to g. Let me write. First, let me write this. When a particle moves under the attraction of the earth, when a particle moves under the attraction of the earth, then the acceleration acting on it towards the center of the earth, will be as follows. Number 1, when a particle moves under the attraction of the earth, then the acceleration acting on it towards the center of the earth will be as follows. Number 1, when a particle moves either upwards or downwards, it is not a problem at all. Upwards or downwards. When a particle moves upwards or downwards outside the surface of the earth, when a particle moves upwards or downwards outside the surface of the earth, then the acceleration varies inversely as the square of the distance of the particle from the center of the earth. When a particle moves upwards or downwards outside the surface of the earth, then the acceleration varies inversely as the square of the distance of the particle from the center of the earth. Number 1. And number 2, when the particle moves inside the surface through a hole made in the earth, then the acceleration varies directly as the distance of the particle from the center of the earth. Number 3. The value of the acceleration at the earth surface, of the earth, Earth is G, is equal to G. What we have written, just when a particle moves under the attraction of the earth, then the acceleration acting on it towards the center of the earth would be as follows. Number one, when a particle moves upwards or downwards outside the surface of the earth, then the acceleration varies inversely as the square of the distance of the particle from the center of the earth. From the center of the earth. Number two, when the particle moves inside the surface through a hole made in the earth, then the acceleration varies directly as the distance of the particle from the center of the earth, and the value of the acceleration at the earth surface is equal to G. Just remember this. When the particle moves outside the center of the earth, acceleration varies inversely as the square of the distance. If it moves inside the earth surface, then the acceleration varies directly as the distance of the particle from the center of the earth, and at the earth surface the value of the acceleration is equal to G. Perhaps you have noted down and you have already remembered it. Now let me try to solve the question number 1. Now I am going to solve the question number 1. What is it? First, what is the question number 1? If the earth's attraction vary inversely as the square of the distance from its center, it is given here. And if it is not given, then also if a particle moves outside the center of the earth, you must assume that the acceleration varies inversely as the square of the distance from the center of the earth. From the center. And G be its magnitude at its surface. If it is also not mentioned, then also the value of the acceleration at the earth surface is equal to G. The time of falling from a height h above the surface to the surface is this. To the surface is this. Now let me first draw the diagram. Suppose this is earth. This is earth. O is the center of the earth. Suppose it is a vertical line within the surface of the earth at A. OAB is a vertical line. OA is the radius of the earth. It is given to be equal to A in the equation. It is given to be equal to A. Suppose P be the, now you see here, the time of falling from a height h. Suppose AB, this distance AB equal to, this is equal to h. AB equal to h. Suppose P is the position, a particle is falling from the point B. Falling from the point B. The velocity of the particle at the point B equal to 0. Velocity of the particle at the point B is equal to 0. From the earth surface, its distance is h. What is this? O is the center of the earth. We draw a vertical line OB to meet the surface of the earth at the point A. At the point A. A particle is falling. We have supposed that AB equal to h. A particle is falling from the point B, from rest, towards the earth's surface. We have to find the time taken by the particle from B to A, that is from a height h above the surface of the earth to the surface is given by this one. Right. Let me first write this one. Let O be the center of the earth. Let O be the center of the earth. We draw a vertical line. We draw a vertical line OB, which meets the surface of the earth at A, which or meeting the surface of the earth at A, which meets the surface of the earth at A, surface of the earth at A, meets the surface of the earth at A, where at A, where AB, this is equal to H, AB equal to H, OA equal to small a, this is equal to radius of the earth, OA equal to small a, radius of the earth. This one. A particle is falling from rest from the point B. A particle is falling from the point A, point B, from the point B, from rest. Suppose at time t, its distance, suppose at time t, the position of the particle is at P. Suppose P is the position of the particle at P. Suppose P is the position of the particle at time t. P be the position of the particle. Position of the particle at time t. Suppose P be the position of the particle at time t, where OP equal to, we are measuring the distance of the particle from the center of the earth, where OP equal to small x. Now, acceleration is what? It outside the earth's surface varies inversely as the square of the distance of the particle. Acceleration will be equal to mu divided by x square. It is in a direction of x decreasing. It is acceleration is in a direction of x decreasing because x is measured from the center of the earth. Oh. Therefore, acceleration will be equal to minus mu by x square. The equation of boson of the particle is, you may write the equation of boson of the particle at P. P is d2x by dt square minus mu divided by x square, right? Minus mu divided by x square. Negative sign has been taken. The particle is moving in a direction of x decreasing. It is attracted. Acceleration, the particle is attracted towards O in a direction of x decreasing. That's all. Suppose this is number 1. The equation of boson of the particle at P is this. Now, at the earth's surface, means at the point A. What is x? X is equal to A. And the acceleration is equal to c. Now at A. Now at the point A. At the point A. That is on the earth's surface. That is on the earth's surface. d2x dt square equal to minus c. X equal to OA. This is equal to A. X is equal to A. Putting acceleration equal to minus A, x is equal to A. Therefore, from 1 we get. Therefore, 1 implies minus z equal to minus mu divided by a square. This means mu equal to z a square. You will get mu equal to z a square. Therefore, 1 will become d2x by dt square equal to minus z a square divided by x square. The value of mu has been found this time. Instead of writing mu, you will have to write z a square. Z a square. Now, This is a differential equation. Standard method, you may write v dv by dx also. You may multiply the equation by twice dx by dt also. Now, multiplying 2 times of dx dt we get multiplying this one, multiplying 2 times of dx dt d2x dt square equal to minus 2 times of dx dt. This means d dt of dx dt whole square equal to minus 2gx square d dt of, just integrate this, x to the power minus 2, x to the power minus 1 by minus 1. You will get this one. If you differentiate this, minus minus will be cancelled. 1 by x square, also dx by dt. It can be written like this. Or d dt of dx dt whole square equal to d dt of twice g x square divided by x. You may write like this. X divided by, you may write like this. Right? d dt of dx dt whole square equal to this one. We write like this. Integrating we get dx dt whole square equal to twice g square by x plus c1. Suppose this is number 3, where c1 is the constant of integration. C1 is the constant of integration. Where c1 is the constant of integration. C1 is the constant of integration. Now, initially the particle was at A, initially at B, initially at B, at the point B, the velocity of the particle was 0. X, what is X? Measure from the distance from the point O, distance from the center of the earth, from O. From O to A it is A, from A to B it is H. It is H. Therefore, it will be X is equal to A plus H. Therefore, from 3 you will get. 3 you will get. Therefore, from 3 you will get 0 equal to twice g square divided by A plus H. This means C1 A plus H. Therefore, from 3 dx by dt whole square equal to twice g by s, twice g square divided by x minus twice g square divided by A plus H. A plus H. This means dx by dt whole square equal to twice g square 1 by x minus 1 by A plus H. 1 by x minus 1 by A plus H. Clear? What will be dx dt? We will have to put a negative sign because the particle is moving in a direction of x decreasing. Particle is falling from B. Particle is falling from B. It is falling in this direction. When it comes towards A, the distance towards A, the distance of the particle from the center of the earth will be decreasing. This means that the particle is moving in a direction of x decreasing. Therefore, we shall take the negative sign. we shall take the negative sign. Let me write like this. Here. This means dx dt equal to minus root over twice g square root over 1 by x minus 1 by a plus h. 1 by a plus h. Negative sign has been taken because the particle is moving in a direction of x decreasing. Negative sign has been taken since the particle is moving in a direction of x decreasing. Since the particle is moving in a direction of x decreasing. Negative sign has been taken since the particle is moving in a direction of x decreasing. Now, you may write here dx by dt equal to minus a root over twice g root over a plus h in x, a plus h minus x, a plus h minus x. This means root over a plus h minus x dx equal to minus a root over twice g dt. Twice g dt. Now, you see, we have to find the time taken by the particle from B to A. We have to find the time taken by the particle from a height h above the surface of the earth to the surface. What does it mean? Time taken by the particle from B to the point A. That means time taken by the particle from when x is equal to a plus h to a distance from when x is equal to a. X is equal to a. Suppose t1 is the time taken by the particle. Let t1 be the time taken by the particle. Be the time taken by the particle. Let t1 be the time taken by the particle from B to A. From B to A means that is, you may write here, that is x is equal to a plus h to x equal to a. That is this. Suppose this is number 4. Integrating 4 we get. Integrating 4 we get. Integrate 4. Integrating 4 we will get integration under root a plus h x divided by a plus h minus x dx. X equal to, this is equal to integral minus a root over twice g dt. T equal to, from B, t equal to 0. At the time x was a plus h. A plus h. When it reaches the point A, it is t1. It will be equal to a. Right? Or if you remove the negative sign, then you may interchange the limit in this integration. The integration in the limit. This means you may write integration a to a plus h. X equal to a to a plus h under root a plus hx divided by a plus h minus x dx equal to a root over twice g integration 0 to t1 dt. You may write like that. Or from this a root over twice g t1 is equal to integration a to a plus h root over a plus hx divided by a plus h minus x dx minus x dx. Suppose this is number 5. We have to integrate number 5. Standard substitution, you will have to put x is equal to a plus h sin square theta or a plus h cos square theta. You may put x is equal to either a plus h sin square theta or x is equal to a plus h cos square theta. Let me put x is equal to a plus h sin square theta. Let me put putting x equal to a plus h sin square theta we get dx equal to a plus h twice sin theta cos theta d theta, twice sin theta cos theta d theta. X equal to a implies sin square theta equal to a divided by a plus h, means theta equal to sin inverse root over a by a plus h. Is not it? X equal to a plus h implies this a plus h will be cancelled. Sin square theta equal to 1, theta will be equal to pi by 2. This means theta will be equal to pi by 2. Theta will be equal to pi by 2. Then the integral in the right hand side of equation number 5 will become, therefore 5 implies, you may write here 5 implies a root over twice g t1 should be equal to integral. When it is a, it will be sin inverse under root a divided by a plus h. A divided by a plus h. When it is a plus h, it is pi by 2 under root a plus h. For x, you will have to write a plus h sin square theta. H sin square theta. For here, a plus h minus a plus h sin square theta. For dx, you will have to write a plus h into 2 sin theta cos theta d theta. Sin theta cos theta d theta. This means should be equal to 2 times of a plus h, but no, we will not take 2 outside this. A plus h, from here a plus h, another a plus h will come. Root over a plus h will come from the denominator, and it will be sin inverse root over a divided by a plus h to pi by 2. It will be sin theta, and 1 minus sin square theta will be there, means cos theta. 2 times of sin theta cos theta d theta. This cos theta will be cancelled. This is equal to a plus h whole to the power 3 by 2, a plus h whole square divided by a plus h whole to the power half. Twice sin square theta, it will be sin inverse root over a divided by a plus h to pi by 2. Twice sin square theta means 1 minus cos 2 theta d theta. 1 minus cos 2 theta d theta. You may write like this. Now, what is the integration of this? Theta. What is the integration of this? Sin twice theta divided by 2. This means A root over twice G T1 should be equal to A plus H whole to the power 3 by 2 theta minus sin 2 theta divided by 2 theta vary from sin inverse root over A by A plus H to pi by 2 A plus 2 pi by 2 this one. Now right, this is equal to A plus H whole to the power 3 by 2 theta minus it will be sin theta cos theta. Sin 2 theta means twice sin theta into cos theta divided by 2 means sin theta into cos theta. It will be pi by 2 sin inverse under root A divided by A plus H. A divided by A plus H. This is equal to A plus H whole to the power 3 by 2. Write the pi by 2 here. Pi by 2 minus it will be sin it will be 0 because sin pi by 2 is 1, cos pi by 2 is equal to 0 minus it will be sin inverse under root A divided by A plus H. It will be plus sin of sin inverse under root A by A plus H cos of sin inverse root over A by A plus H will be there. Just put the bracket. Now, it will be equal to 0. Cos pi by 2 equal to 0 means this term will be 0. Pi by 2 minus this. This is equal to A plus H whole to the power 3 by 2. Pi by 2 minus sin inverse theta equal to cos inverse theta. This will be equal to cos inverse under root A divided by A plus H plus it will be root over A by A plus H. What is cos of sin inverse this? What is cos of sin inverse this? Will be equal to root over 1 minus root over A by A plus H whole square. Is not it? Cos of sin inverse theta. Cos of sin inverse theta, suppose. Cos of sin inverse theta. Cos of x equal to root over 1 minus sin square x. Cos of x equal to root over 1 minus sin square x. Cos of sin inverse theta will be equal to this. Cos of sin inverse root over A divided by A plus H should be equal to under root 1 minus sin of sin inverse root over A by A plus H. This whole square. Which is equal to root over 1 minus under root A divided by A plus H. Whole square. A divided by A plus H whole square. This is equal to A plus H whole to the power 3 by 2 it is cos inverse under root A divided by A plus H plus under root A divided by A plus H. Again under root, here it will be A plus H. A plus H minus A. A plus H minus A. This is equal to A plus H whole to the power 3 by 2 cos inverse x. Suppose cos inverse x is equal to theta. This means cos theta is equal to x. This means cos square theta is equal to x square. This means 1 minus sin square theta equal to x square. This means sin square theta is equal to 1 minus x square. This means sin theta equal to root over 1 minus x square. This means theta equal to sin inverse root over 1 minus x square is nothing. Theta equal to sin inverse root over 1 minus x square means cos inverse x should be written as sin inverse root over this. In the answer you will see here it is sin inverse. Therefore we should convert cos inverse x to the sin inverse x. Cos inverse this will be equal to sin inverse root over 1 minus x square, x means this, root over this whole square, a divided by a plus h, root over this whole square, you may write like this also. Or here it is a plus h, a will be cancelled, under root ah, and in the bracket you may write since cos inverse x equal to sin inverse root over 1 minus x square. Since cos inverse x equal to sin inverse root over 1 minus x square. Like this. We have to find the value of t1. It is a root over twice g t1 is equal to this. Therefore t1 now t1. This means t1 equal to a plus h whole to the power 2 by 3 can be written as like this. A root over twice c. Can I write a plus h whole to the power 3 by 2? What is this? It is equal to a plus h root over a plus h. Sin inverse. In the bracket it will be sin inverse 1 minus a divided by a plus h. A plus h minus a plus root over ah by a plus h. Ah by a plus h. This is equal to root over a plus h by twice g. Take it common. And you may write a plus h by a. Sin inverse. This a will be cancelled, h divided by a plus h. Of course, it is under root. It is under root. Plus a plus h divided by a. Root over a h into root over h divided by a plus h. Right like this. Now, this is equal to root over, not, it is a plus h, not a plus h. It is a plus h should be equal to a plus h. A plus h divided by twice g. Twice g. It is a plus h by a sin inverse root over h by a plus h. A plus h will be cancelled. A plus h will be cancelled. In the numerator it will be root over h. In the denominator it will be root over a. Combinedly we can write root over h by a. Root over h by a. It is exactly we have done this. Hence proved. Hence we have proved this. Hence proved. The time taken by the particle from a height h above the surface of the earth to the surface is given by this. Therefore, the time taken by the particle from a height h above the surface to the surface is equal to this. Or simply time taken from B to A equal to this. Therefore, we have proved number 1. Now, we shall prove number 2. Number 2. Number 1 has been proved. Thus, let me remove this. Number 1. Since it has been proved, remove this. Number 2. If h be the height due to the velocity v at the earth surface, supposing its attraction constant, motion under constant acceleration, attraction constant, and h the corresponding height when the variation of gravity is taken into account. Prove that this one. What is this? If h is the height due to the velocity v at the earth surface, supposing its attraction constant. First, let me draw another diagram. Suppose this is the center of the earth. It is A. Suppose it is B. Now, a particle is projected from the point A. The particle is projected from the point A. Upwards, vertically upwards. P is the position of the particle at time t. Suppose OP, this is equal to x. Suppose this is equal to x. You may write, let O be the center of the earth. Let O be the center of the earth. We draw a vertical line OB to meet the surface of the earth at A. We draw a vertical line OB. Vertical line OB to meet the surface of the earth at A. To meet the surface of the earth at A. Let O be the center of the earth. We draw a vertical line OB to meet the surface of the earth at A. A particle is projected vertically upwards with velocity v from the point A. A particle is projected vertically upwards from the point A with velocity v. You see what I am going to do. Two cases arise when the attraction constant with velocity v. Two cases arise. Case 1, when the attraction constant, when the acceleration is constant. Suppose here you see h is the height. H is the greatest height. Means h is the height when the velocity of the particle is equal to 0. Velocity of the particle is 0. A particle is projected vertically upwards. Its velocity will be decreasing. Because the particle is moving under gravity and it is moving upwards. Its velocity will be decreasing. At a time, its velocity will be equal to 0. That time, when the velocity of the particle is equal to 0, at that time the distance covered by the particle is h. It is given in the question. When velocity becomes 0 when it covers a distance h. So when a particle is projected vertically upwards with a velocity v under gravity, with a velocity, if h is the distance covered by the particle, when its velocity becomes 0, means in other words, h is the greatest height attained by the particle. In other words, h is the greatest height attained by the particle. Now use the formula. What is the, if a particle is projected vertically upwards, what is the formula? V square equal to u square minus twice gx. Using the formula, v square equal to u square minus twice gx, we get final velocity 0 square equal to initial velocity v square minus twice g. It is given to be equal to h. This means v square is equal to twice gh. V square is equal to twice gh. V square equal to twice gh. Suppose this is number 1. V square is equal to twice gh. This is number 1. Case 1, we have now case 2. When the variation of gravity is taken into account, suppose let P be the position of the particle. P be the position of the particle at time t. Where OP equal to, let P be the position of the particle at time t where OP equal to x. The equation of motion of the particle is given by outside the surface of the earth, therefore x double dot equal to minus mu by x square. Acceleration is towards O. Negative sign has been taken. In this case also, x double dot is equal to minus mu x square. Suppose this is number 2. X double dot is equal to minus mu x square. This is number 2. But at the earth surface A, x double dot d2x dt square equal to minus g, x equal to r at that time. because r is the radius of the earth. X is equal to OA, you may write OA equal to r, equal to radius of the earth. Radius of the earth. Therefore, 2 implies, from 2 you will get minus z equal to minus mu divided by a square. This means mu equal to z, or not a square, it is r square. Z r square. Mu equal to z r square. Putting mu is equal to z r square in 2 we get, therefore from 2 you will get x double dot. X double dot means d2x by dt square equal to minus z r square divided by x square. Z r square divided by x square. Multiply both sides by twice dx by dt. 2 times of dx by dt, d2x by dt square equal to minus 2 times of z r square divided by x square. Dx by dt. This means d dt of dx by dt whole square equal to minus twice z r square d dt of x to the power minus 1 by minus 1. You may write like this, because if you differentiate this, you will get this one. Number 1, I am writing here, v square is equal to twice zh. It is number 1. This means dx by dt whole square equal to d dt of twice z r square by x. D dt of r square by x. Integrating we get dx dt whole square twice z r square divided by x plus, suppose c1 is the constant of integration. C1 is the constant of integration. Dx by dt whole square is equal to this. Now we have to find the value of the constant of integration. Suppose this is number 3. This is number 3. Initially, what is the initial position of the particle? Initially the particle was at A. Initially at A. At the earth surface A. Then what was the velocity of the particle? Velocity was v. It is given in the question. Dx by dt, this is equal to v. What is x? X, it should be equal to r. X is equal to OA equal to r. X is equal to OA. This is equal to r. Equal to radius of the earth. Dx dt equal to v, x equal to r. Therefore from 3 you will get. You will get v square equal to twice z r square divided by r plus c1. This means c1 equal to v square minus twice z r. R will be cancelled. C1 will be equal to v square minus twice z r. Put the value of c1 in 3. Therefore, putting the value of c1 in 3, value of c1 in 3 we will get dx by dt whole square. This is equal to twice z r square by x plus v square minus twice z r. Suppose this is number 4. This is number 2. According to the question, this time, capital H is the height. This time, capital H is the greatest height attained by the particle from the point A. When the variation of gravity is taken into account. According to the question, the velocity is 0. dx dt will be equal to 0 when x equal to, from the surface of the earth its distance is h, capital H. From the center of the earth it will be r plus h. Is it clear? From the point A, see the diagram, from the point A, the particle is projected vertically upwards with velocity v. Its velocity will be decreasing. Once at a time, the velocity of the particle will become 0. When the velocity of the particle becomes 0, its distance from the surface of the earth is given to be equal to capital H. But its distance from the center, what will be its distance from the center? X represents the distance from the center. Therefore, its distance from the center will be equal to r plus h. Putting this in 4, we will get. Therefore, putting dx dt equal to 0, x equal to r plus h in 4, putting dx dt equal to 0, x equal to r plus h in 4, we get. It will be equal to 0, equal to twice z r square divided by r plus h plus it is v square minus twice z r. This means 0 equal to twice z r square by r plus capital H plus twice z small h minus twice z r by 1. By using 1. By 1. You may write by 1. V square equal to by 1. V square is equal to twice z h. We have applied this one. For v square, put twice z h. Now, 2 will be cancelled. Z r square by r plus h plus zh minus zr. Gg also will be cancelled. Gg will be cancelled. 2 will be also cancelled. It will be r square by r plus h minus r equal to 0. Or you may write r minus r square by r plus h equal to h. You may write or r plus h, r square plus rh minus r square equal to h. R square cancel. RH divided by r plus h equal to h, or r plus h divided by rh equal to 1 by h. Let me write here. This means r by rh plus h by rh equal to 1 by h. This means 1 by capital H plus 1 by r equal to 1 by small h, or 1 by h minus 1 by capital H equal to 1 by r. Hence proved. Small h is the distance when the particle is projected with velocity v. Acceleration is constant. Variation of gravity is taken into account. The greatest height attained by the particle is capital H from the surface of the earth. If A and R is the radius of the earth, if it is so, then the relation between small h, capital H and R is equal to 1 by h minus 1 by capital H equal to. Perhaps you have enjoyed the class. Thanks for attending the class, my dear students. Thank you very much.